Definition of a planet. At the International Astronomical Union meeting in 2006, astronomers adopted a set of criteria for classifying a celestial object as a planet. Based on this definition, a planet should satisfy the following characteristics: 1. Orbit the Sun, 2. Be large enough to sustain under its gravity, and 3. Attract all the smaller bodies in its proximity. This definition of a planet has nothing to do with science and hence could change. The terrestrial planets were formed on the inner part of the gas cloud where the temperature was very high, while the Jovian planets were formed in the cooler outer part. In the regions of the gas cloud where temperature is lower, the gas condenses, atoms and molecules bond without being broken due to the energy caused by high temperature. This process is called condensation. Given that different elements condense at different temperatures, the composition of the planets depends on their distance from the Sun. For example, materials consisting of hydrogen compounds, water vapor H2O and methane CH4, condense at low temperatures around 150 degrees Kelvin. While rocky materials, which are in the gas form at very high temperatures, condense and turn to solids at higher temperatures around 500 to 1300 degrees Kelvin, and metals, consisting of iron and nickel, condense at even higher temperatures around 1000 to 1600 degrees Kelvin. As a result, at the very inner part of the Solar System, where the temperature was above 1300 degrees Kelvin, none of the material could solidify and condense. As the temperature reached around 1300 degrees Kelvin, roughly at the orbit of Mercury, metals and some kind of rocks were condensed and turned into solid bodies, while other material was still in the form of gas. Around the region where Venus, Earth, and Mars are, the temperature reached below 1300 degrees Kelvin, allowing condensation of rocks and metals. Hydrogen compounds could only condense in the outer region of the Solar System and beyond the frost line, where the temperature reaches 150 degrees Kelvin. The frost line is between the orbits of Mars and Jupiter and determines the division between the warm inner part and cold outer part of the Solar System, where the terrestrial, rocky, and Jovian, gaseous planets are separated. Hydrogen and helium that contain 98% of the gas cloud never condense and hence are only found in the form of gas throughout the Solar System. Therefore, the condensation process leads to the formation of seeds with different elemental abundances, depending on their distance from the Sun and hence their temperature. The seeds will grow by attracting more matter under their gravity, eventually forming the planets we see today. The origin of the planets. The previous section introduced the two types of planets, terrestrial and Jovian. Terrestrial planets are small, were formed in the inner parts of the Solar System, and are made up of metal and iron. Jovian planets are large, are found in the outer parts of the Solar System, and are dominated by gaseous hydrogen compounds. The fundamental distinction between the two types of planets and their different compositions imply that they have had different formation histories. Terrestrial planets are relatively small because their main constituents, metal and iron, are very rare in the Solar System. The seeds formed by condensation of these materials gradually attract other small particles as they orbit the Sun and grow in mass and size. Due to their small size, their gravity is weak and does not play a major role in attracting other bodies until the system further grows. At this point the seeds grow and gravity eventually takes over and larger and smaller objects attract one another, growing in size and forming planetesimals, meaning parts of planets. Collision between the planetesimals is violent, since they move fast. This results in the destruction of smaller systems and a change in their orbits. As a result, only larger planetesimals survive and orbit the Sun. Small planetesimals that were not attracted by larger ones are currently floating in the Solar System and are called meteorites. Every now and then, some of these meteorites pass through Earth's atmosphere and reach us. They reveal traces of heavy elements. Jovian planets contain significant amounts of ice as well as metals and rocks. They also attract hydrogen and helium gas, which are the most abundant elements in the Solar System, and this is the reason for their large sizes. From left to right, larger planetesimals are accreting the smaller ones and growing bigger. Given the larger mass of the outer planetesimals, they have stronger gravity and attract more of the smaller planetesimals. Conditions for planets to harbor life. To harbor life, a planet must satisfy the following conditions. It must be associated with a star with a long enough age to allow life to develop. This excludes hot, high-mass stars that have short lifetimes, restricting the search to a class of low-mass stars, a few times the mass of the Sun, only. It must reside within a region at a distance from its star to allow water in liquid form that is not too hot or too cold. There is a region called the habitable zone where water is found in liquid form. For low-mass stars the habitable zone is closer to the star, while for higher-mass stars, it is further away. Therefore, the size and location of the habitable zone depends on the luminosity mass of the central star. As the luminosity of a star changes with time, the size and location of its habitable zone changes too. It must have a mass sufficient to retain an atmosphere. The pressure in the atmosphere should also be sufficient to keep water in liquid form. It must contain the chemical composition needed to support life. It must be a terrestrial planet and hence closer to its central star. The Kepler satellite has discovered many planets that resemble the Earth. For example, Kepler 186f is found to orbit a faint red dwarf star about 490 light-years from Earth. The planet is bigger than the Earth, but the distance from its star and the size of the planet suggests that it could contain liquid water. Summary and outstanding questions. The prevailing scenario for the origin of the Solar System is the nebula theory that proposes formation through collapse of rotating gas clouds in the interstellar medium. The gas may be pristine, only containing hydrogen and helium and not enriched by heavier elements, or constitute processed material from previous generation of stars rich in heavy elements. The planets were formed within these clouds from the condensed gas collapsed under the force of gravity. These are called the planetesimals that attract other systems, growing in size to form the planets we see today. This scenario explains current observations as to why the planets are all located on the same plane, moving in the same direction and are separated depending on their mass, size, and composition. There are two types of planets, terrestrial and Jovian. The terrestrial planets are formed closer to the Sun where, because of the extreme heat around 1300 degrees Kelvin, only iron could condense to form the core of the planet. Most of the elements at this temperature are melted and found in gas form. The Jovian planets, on the other hand, are located further away from the Sun, are much larger than the terrestrial planets, are more massive, and mostly contain gas.